Okay, Assalamualaikum warahmatullahi wabarakatuh. Welcome student to MEC 672 Flight Economics and Control. This is lecture series of week 8. Now, let's proceed. Okay, so kita proceed dengan stick fixed longitudinal motion. Basically, there are two types. Okay, the first one is called the long period or phugoid. Okay, and the second one is the short period oscillation or short period lah. Okay, so if you look at this picture, okay, what happened in the long period of phugoid? It's a kinetic and potential energy interchange. So basically, there will be change in altitude and airspeed, okay, especially the forward airspeed. And this kind of motion occurs at constant angle of attack. And it is also lightly damped oscillation. So most likely you will find that the damping ratio is on the low side, perhaps very low. Okay, so it's a low value of damping ratio. So what happens is if you begin with this at the high altitude, okay, at a high altitude, so what happens bila dia turun, okay, at high altitude it has a maximum potential energy, but kinetic energy dia dah sampai max lah, okay, so energy is constant in this case. So what happens is dia akan drop down. When it drop down, it increases the energy until it reach a maximum speed. So bila dia reach maximum speed, dah cukup speed dia dapat tu, okay, the lift akan jadi lebih daripada weight dia. Okay, the lift akan jadi lebih daripada weight dia, and kemudian dia akan manjat balik. Okay, it will climb up. Okay, it will climb up. Okay, until they reach its maximum potential energy. Okay, and that when it reaches minimum speed, yang mana lift dia dah kurang berbanding dengan weight, dan kemudian dia turun balik. So long period oscillation of phugoid will take about 30 seconds or more. Kadang-kadang lagi lama kan. Okay, few minutes. But takkanlah kita nak biarkan terbang ni naik turun lama-lama kan. Jadi something must be done lah. Okay, so when you design an airplane, we don't want this to be long because annoying lah. And untuk navigation yang memerlukan ketepatan, okay, especially kalau UAV, kalau macam ni UAV naik turun 1-2 meter, 2-3 meter, okay, masa nak landing susah lah bang, okay, crash lah, so benda ni mesti dihilangkan kalau boleh lah, kalau boleh. So naturally sekarang kita nak tengok lah dia macam mana behavior dia. Okay, for short period, okay, for short period, it only yang berlaku adalah change of angle of attack. Okay, pesawat tu bergerak lurus je, okay, tak ada naik turun, but angle of attack yang berubah, meaning that the pitch angle tu, okay, kapal terbang tu akan angle naik turun. Okay, but this occur very short time, okay, 1 second, 2 second, or maybe several second, tapi lepas tu dia hilang. Okay, hilang. So this motion occur at nearly constant speed. Okay, at nearly constant speed. Okay, and tengok dia beberapa saat hilang. Okay, or jadi less than that pun. Okay, but reality ini boleh jadi this short period oscillation ni, kalau dia aircraft tu kena disturbance, dia akan duduk dekat dalam phugoid ni. So dalam phugoid ni ada short period oscillation, lepas tu dia hilang, lepas tu terbang tu akan continue dengan constant angle of attack, dia akan phugoid. Okay, dia akan phugoid terus. Okay, that can happen lah. Okay, dia mungkin berlaku separately, but maybe most of the time dia berlaku sekaligus, but short period dia habis dulu, and then kemudian dia baru long period. Okay, now kita go to mathematics. if you look at equation 449, as this is something that you have seen before in control engineering course MEC 522. Okay, except that this HEPA ni in Ogata textbook is U kan, huruf U. So sama je. So basically x dot is equal to AX plus BU. So this is the first matrix, and you have another matrix kan. Kalau you ingat balik, Y, which is the output, is equal to CX plus DU. Okay, so I think you know lah what is the meaning of A. Okay, the state matrix, X is the state vector, and then B is the input matrix, and HEPA or U is input vector. Okay, so in this case dia tak panggil input, dia panggil control vector. Because why control? Because it's the control. It's coming from the control surface. For example, from the elevator, okay, from the thrust of the engine, from the aileron, from the rudder, or kalau thrust vector tu ada vector kan, ada boleh. So basically it's from the control system that control the motion of the aircraft. Okay, so now let's look at the three main longitudinal equation. Okay, so dalam previous chapter kan kita dah derive kan. Okay, already derived this. So ada 3 untuk longitudinal and another 3 from for lateral directional. For longitudinal we have 2 forces and 1 moment. Okay, we have forces in X direction, maknanya forward force, and then we have vertical force in Z direction, and also a pitch moment. Okay, pitch moment. Now if you look at this, on the left side is aerodynamics and gravity. Okay, which is basically yang kita tak boleh control. Okay, ini sifat semula jadi pesawat, dan ini sifat dia buat dia kat atas bumi, because ada gravity di effect. Sama juga if you look at on the left side of the Z equation, ini aerodynamic. Okay, aerodynamic. These are all derivative kan, aerodynamic derivative and gravity. Okay, same goes to the moment. Okay, sama. On the right side, it's a control. Okay, control forces. Okay, like this. This is coming from the elevator, and this is coming from the throttle. Kan? Okay, thrust. Okay, so dalam case ni kita ada elevator dengan throttle. Dan apa impact dia pada X force? So sama juga. For the same input from the elevator and throttle, apa pula input dia pada Z force? And yang ini pula, okay, same thing, apa pula input dia pada pitch moment? So dalam semua equation, of all these equations, you find that they are ada benda yang ada D over dt ni. So D over dt over delta U is basically acceleration, sebab U tu velocity. So D over dt ni kali delta U, of course lah, it is acceleration. So dia ada acceleration kat sini. Ada lagi acceleration lain. So far equation ni tak ada lah. Okay. For second equation Z, okay, we have this d over dt over delta dw, delta w. Please take note. Okay. So ada acceleration juga. Acceleration in Z direction. So ada acceleration kat sini. Yang lain ni semua velocity. And we have also d over dt, okay, of theta. Theta is angle. Okay, bukan angular velocity. It is an angle. So d over dt of that angle is pitch rate. Okay, because this is pitch angle. So d over dt over theta is pitch rate. So meaning that you can also call it Q if you want. Okay, so jadi Q. And in fact sebenarnya perkali yang sebelah kat sini dah set Q. Okay, so ada acceleration dah. Walaupun kita nampak ada U, W and theta, but actually ada satu lagi, ada Q pula. Okay, let's look at the moment. Ini ada really tricky. So we have d over dt over W. Now this is acceleration juga. Okay, acceleration. So W is a vertical speed, vertical velocity. Okay, and dia ada d squared over dt squared over kali kan delta theta. So what is this? This is angular acceleration. Okay, angular acceleration. D over dt. Okay. Now, bila ada d over dt, ni senang lah. Maknanya benda ni ialah delta u dot. Delta u kali dengan d over dt dapat u, delta u dot. Okay, ada itulah, ada tanda nanda atas tu kan. So sama juga ini pun delta w dot. Okay, sebab dia kali dengan dt. Okay, this part je lah, ni kali ni je lah, ini bukan. Okay, so tapi kalau yang squared ni macam mana? Kan, macam mana kita nak buat AX plus BU ni? Kan, X dot tu nak dapat mana? Jadi yang ini kita convert jadi Q, senang. Okay, kalau ini kali ni jadi Q, jadi Q. And ini akan jadi D over dt delta Q. Okay, nak kasi senang. Apa benda aku cakap ni? Kau faham ke? Okay, tengok sebelah sini. Ni dah equation tadi, delta U tadi. Okay, so XU kali dengan delta U campur XW kali dengan delta W campur 0 kali Q campur negatif G kali delta theta. Tengok balik sebelum ni kan, betul kan? D dt XU. Ini delta U dot. And then XU kali delta U. Okay. XW delta W. Okay. Ini tak. Kenapa G je? Mana cosine ni? Sebab angle theta not ni kecil. So cosine yang theta kecil 1. So it simply kali dengan G je lah. Okay. Tapi kalau nak detail pun boleh. Sebenarnya nak letak lah. Okay. Nak letak lah. So then you have this not negative G but negative G cosine theta dot. It doesn't matter. If you like it, why not? Okay. So equation kedua ialah ini. Okay. Delta W dot is ZU kali delta W. ZW kali delta. Delta U. ZW kali delta W. U not kali Q. 0 kali theta. Confirm balik equation yang kedua. Betul? Ni acceleration ni kat mana? Acceleration dia kat mana kat sini acceleration ni? Sini delta W ni acceleration dia. Okay. So ZU delta U plus tu ada ZW delta ni. Okay. Show balik. Kan? ZW. Okay. And then ZQ. Ini kita convert jadi Q. Okay. Convert jadi Q. Nah ini nak jadi apa pula ni? Now, sin theta dot, since theta dot ni kecil, sin dia lah kosong. So this part boleh potong lah. Hilang. Jadi tinggal ini je. So ini d over dt kali dengan delta theta. Jadi delta Q. Okay, so U naught plus ZQ. See? U naught. Mana ZQ dia? Tak taruh. So boleh je nak taruh. Okay, boleh nak taruh. Nak taruh pun boleh. Tapi dalam kes ni dia assume dia neglect ZQ. Sebab apa? Kecil sangat nilai dia. And also ZW dot. Okay, pun dia neglect. This part also neglect because it's kecil sangat. Okay, so small. Jadi kalau tak ni lagi banyak ni nak bagi ni. Susah kan? Sebab ni kan acceleration. Okay, ini acceleration W kan. Okay. So, and then dekat bawah ni semua, yang ni dia tak pakai theta, dia pakai Q. Okay. So the third equation, okay, acceleration dia adalah Q. So dia pakai Q. So delta Q dot acceleration. And ini mu plus mu bla 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 kan. Yeah. Ni malam datang ni. Okay. So inilah dapatlah benda-benda ni panjang ni dapat Q. Okay. Now theta dot ni apa dia buat? Dia cuma buat conversion je. Theta dot adalah okay, equal to 1 kali delta theta, that's all. Itu je. Okay. Now equation ni tak habis sebab ada sebelah sini ya. Ada yang control kan. So ini akan jadi matrix B. Okay. If you look this part of this equation, okay, yang ada kat sebelah kanan ni, ini jadi matrix B. So ini yang jadi dia punya matrix dalam, and yang delta ni dia punya control vector. So control vector 2. So dia 4 kali 4. So ada 4 kali 1. And this is 4 kali 2. And this is 2 kali 1. Okay. So ini dah complete. Okay. So ini cuma matrix AX plus BU or B HEPA. Okay. Only this. Alright. Now I'm going to stop now.